It's really an honor for me to be at the 100 Grannies Barbara Schlachter Memorial Lecture Series. Barbara was a good friend of mine. And Joan, you may know that we did several gigs together, Barbara and I. When she, and as you know, she fought right up to the end and a real inspiration to me. So let's hear it for the 100 Grannies and Barbara Schlachter. This is the big blue marble we're trying to protect, and it really is. We don't have a planet B. We only have the planet A, at least right now. And unfortunately, with $80 trillion gross world product and 7.7 billion people, we're stressing it quite a lot. This very thin veneer here, it's about 50 miles deep. You can't even hardly see it on the slide, but that's our atmosphere. And that's what we started to change fastest and first, because it's a small reservoir held closely to Earth by gravity. And when you have emissions where you're burning fossil fuels that took 340 million years to form, and you're releasing them in just a couple hundred years, you're going to change the atmosphere, being that it's so small. What I never would have figured out, and I may have said this to you before, as a student at Iowa State University back in the day, if you would have told me we could change the entire oceans, 70% of this big blue marble surface area, that we could change the temperature and the chemistry of the oceans in my working lifetime, I would have been really skeptical. I would have said that that's impossible. That's crazy. But we're doing it, unfortunately. The gist of the problem is kind of shown in a nutshell here. Burning the fossil fuels that took, in Saudi Arabia, the oil there took 50 million years to form. The coal that we're burning in the Powder River Basin from Wyoming took about 340 million years to form. All that carbon, and now we're releasing it to the atmosphere. That's the red arrows. And the two red arrows here, I'll try to get my pointer going, my cursor. Where is it? There it is. The red arrows are bigger than the black arrows. That's the carbon dioxide going into plants to make wood and soil. And then black arrow here, that's the carbon dioxide absorbed by the ocean. If the red arrows are bigger than the black arrows, and they are, you've got an accumulation in the atmosphere. And we do. We've got a major accumulation of gases. It's our exhaust, basically, from burning all those fossil fuels in the atmosphere. It wouldn't matter too much, but that the carbon dioxide and other greenhouse gases are radiatively important. That means they change the energy balance. They absorb back radiation coming off of the Earth, and like putting a blanket around that 50-mile veneer that we looked at earlier. And because of that, we've changed the energy balance of the Earth, and it's had a lot of repercussions. So pre-settlement, back in the beginning of the Industrial Revolution in the late 1700s and early 1800s, we were at about 280 parts per million here on the y-axis, and it's gone steadily up since then. That's when we started to burn large quantities of coal. The steam engine was invented, and the Industrial Revolution started, and it's just gone up and up and up ever since then. If this were your blood gases and you were checking in at the doctor, I think you should be kind of concerned. This is the gases in our atmosphere, and they're radiatively important. So yeah, we should be concerned. We're now at about 415 parts per million. And you know, the up and down interannual variability is due to the so-called lungs of the Earth, where this observatory is in Mauna Loa, Hawaii. That's in the northern hemisphere, where these measurements are made. And when the trees come out in the spring, they suck carbon dioxide out of the atmosphere, and the red line goes down. And then when they lose their leaves in the fall and they get oxidized, the carbon dioxide goes up. But the strong signal, this exponential rise, is due to more and more people, more and more fossil fuels being burned.
We have a question in the chat.
Yes.
If we convert over to solar or electric cars, can we reduce the carbon balance in the atmosphere?
We can turn it around, yes. But I'll show you, it's going to take a lot. But yes, we can. It is largely reversible, not all aspects, but largely reversible if we can stop burning fossil fuels. This is a 800,000 year going backwards. So here's today, here's back in time, 800,000 years from ice cores, in which bubbles are trapped in ice cores in Antarctica. We can date that, and we can even melt the sections of the core and suck the bubbles off, the air bubbles that were trapped at the time that that ice was laid down. And you can see here, these are glacial maximums when it was rather warm on Earth and CO2 was high. And this is caused also by a change in the energy balance of the Earth, the glacial cycles. About every 100,000 years, we go through a glacial cycle, and it's because of the planets Jupiter and Saturn having, they're huge planets, and they have a big gravitational pull on Earth. They have irregular orbits, and that causes Earth to have an irregular orbit in three different ways, three eccentricities, as they call it. Our angle that we present ourselves with respect to the sun, our perigee and apogee of our orbit around the sun, and the wobble. We wobble like a top as we go around the sun. All three of those are affected by especially Jupiter and Saturn gravitational pull, and it pulls us in and out of cycles, glacial cycles. Right now we're in a warm cycle. We have been for the last 10,000 years. Right here, if I can find my cursor. Here we are at the end of an ice age, and the ice is melted. And in 14,000 years ago, we had a mile of ice on Ames, Iowa. A mile of ice. The Earth is still decompressing from all that ice expanding due to the last glacial cycle. But we also might know that 200,000 years ago is when culture really, well, at least humans really began. You know, we're the only species in the Homo genus, Homo sapiens. Earlier there was Homo erectus, there was Homo habilis, but only one made it. That's Homo sapiens, us. And we emerged as a force in about 200,000 years ago. And our entire history and culture, everything, evolution, has occurred since that time when CO2 was low. And here we are now. Never before in the history of even 800,000 years of glaciation have we ever been this high in carbon dioxide. You have to go back about to the Eocene, about more than 30 million years ago to find concentrations so high. Well, because the fossil fuel emissions have gone up in our lifetime, somebody asked, can we reverse it? And the answer is yeah, if we stop burning fossil fuels. But the rate that we need to do that in order to stabilize the climate is stark. You may see right here is due to COVID-19. For the first time in our lifetime, well, there was a little bit in the Great Recession of 2007 and 8, but this is the first time we've been able to reduce our emissions with COVID-19 because of not driving so much and not flying so much. It was only about a 7% reduction in emissions for the whole Earth. But we need to continue along that path all the way down for the next 10 years to get down to something like this, just to begin to stabilize climate. So our atmosphere is unstable. It's going up and up in carbon dioxide concentration and other greenhouse gases. And our climate is therefore unstable. And to get a handle on it, we have to go back, all the way down and reduce our use of fossil fuels. By 2030, we need about a 50% decline from the peak right here. Of course, when you've got that many emissions and they affect the energy balance of the Earth, the temperature is going to go up. And it really started about, for sure, about 1980 or so. And that's when I say the signal emerged from the noise. The noise is this interannual variation we get in average temperature on Earth. And this is the difference from average. We're taking the average as a period before climate change kicked in, about from 1880 to 1920. If we take that as an average, we're now about 1.1 or 1.2 degrees Celsius. That's about 2 degrees, more than 2 degrees Fahrenheit warmer than we were back in the turn of the 20th century. So it really kicked in about 1980. The signal emerged from the noise, and it's clear that we're warming, and we're warming rapidly. Now, that's on the global average. Each year, we set about 2 or 3 times more warm temperature records at locations around the Earth compared to cold temperature records. So it's not to say we won't have some cold days. We still will, but they're much less frequent than the warm temperature records that we're setting, and as indicated by this average temperature increase here. We've known since 1859 at least that these greenhouse gases like carbon dioxide, CO2 here, absorbs back radiation from the Earth, infrared radiation, long wave radiation. Other gases do it too. Water vapor does it, H2O. In fact, most gases that have more than 2 atoms per molecule can vibrate and rotate when they receive this back radiation. That vibration rotation is heat. It causes heat, kinetic energy, and that's what's warming our atmosphere. Tyndall proved it back in 1859 experimentally, and it's a fact that adding these gases to our atmosphere will change the energy balance, and it has. It's not only that, we have lots of lines of evidence. Taken as altogether, it's a very compelling case that climate change is real, it's here, it's due to us, and it has started already. And it's going to get much, much worse if we don't contain those emissions that we looked at earlier. If you want to prove that Earth is warming due to these gases, the place you should look is the oceans. Remember our first slide of the blue marble? The oceans cover 70% of the Earth. They're the largest mass on Earth. They have the most heat capacity. About 93% of all the warming that is occurring in the atmosphere is being transferred to the oceans. So if you want to see where the heat is going, you should look in the oceans. We never did that in a very systematic way until about 2005, when the US and many other nations started a program, international cooperation program called Argo. And Argo is now up to over 4,000 floats or SANs. You can see on this global map where all the SANs are. They cover all the great oceans of the planet. And you can see one of the SANs right here, floating in the ocean. It comes up about every 8 or 10 days and recharges its batteries based on the sunlight and sends out all its data to satellites. Then it goes through a programmed dive, and that dive takes it down to 2,000 or more meters, and it records very, very carefully the temperature, the pressure, and the salinity all along its 8-day or 10-day journey before it gives up its data and recharges its batteries. Since that time, 2005, when this program started, we began for the first time to really be able to measure the heat content of the oceans, and that's where most of the heat is going. This is a NASA plot of that data showing the heat content going up, up, up since 2005, steadily up. It's about 0.7 watts per square meter. That's about the energy of, one of these small Christmas tree bulbs on every square meter of the Earth, turning it on and allowing it to go constantly, day and night, every minute, every year, continuously. It's a lot of heat. I have my students compare the amount of heat that's going into the oceans from climate change to how much heat is produced from burning all of those fossil fuels. And it's roughly 20 times more heat is occurring due to climate change than the heat that we add from simply burning the fuels. The other problem with CO2, carbon dioxide, it's in our Coca-Cola, and we're drinking it and we use it for dry ice. But the other problem is not only that it's a greenhouse gas, increasing the energy balance and the temperature of the Earth, but it's also a weak acid. It's one of the reasons we have acidity in our Coca-Cola. And when that atmospheric carbon dioxide, shown here, this is that CO2 signal we saw earlier at Mauna Loa, going up, 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 up. This is the CO2 in the atmosphere. It's transferring into the oceans. This is the CO2 in the oceans. And because it's a weak gas, because it's a weak acid, the pH is going down, which means the oceans are becoming more acid. So again, in my working lifetime, the acidity, the hydrogen ion acidity of the oceans has gone up about 40%. So not only are we changing the temperature of the ocean, of the entire oceans, we're changing the chemistry of the entire ocean in our lifetime, if you can imagine. What that does is in the Arctic, it causes the ice to melt. So this white ice yields a dark sea as it melts. It doesn't change sea level because it's already floating in the Arctic, but it does cause a big increase in temperature. The Arctic is increasing in temperature more than twice as fast as we are here at 42 degrees northern latitude. This is the rate that we're losing the ice. We know this from satellite data very well. Again, it doesn't change sea level that this ice is melting, but if you're a polar bear and you have to make a living fishing off of this ice, you're in trouble. And indeed, the polar bears are in real danger of ultimate extinction. It's estimated by the U.S. Geological Survey we'll lose 2/3 of them in a 50-year period, and it's already starting. Now, the ice on Greenland is a different story. It's up on land, and it's melting very fast. As you can see here, this is what's called a crevasse or a moula, in which the meltwaters in the summertime drops down, straight down a shaft, all the way to the land. And the concern is not only that it raises sea level, it does. This meltwater is about equal to the volume of half of Lake Erie each year. So we're losing about half of Lake Erie's volume each year from Greenland, just in the ice melt, not counting the icebergs breaking off and calving. But we worry about this water lubricating the surface between the land and the ice, and there are glaciers that are falling off by gravity, glacial speed, right? Well, maybe not. If we lubricate the land ice surface, they could fall off much faster. When we worry about that, it's called a tipping point. And Greenland has enough ice on it to raise sea level by 7 meters if it were to abruptly fall off. You may have seen this week there was another large ice shelf collapse off of Western Antarctica. We know the rates reasonably well, again, from satellite data. And Greenland contains enough ice on land, it's a continent, as you know, enough ice to raise sea level 58 meters. So we have to go back to the Eocene in order to 65 million years ago, when sea level was about 200 feet higher than it is now. That's where we're ultimately heading if we don't stop this problem. Not soon, however. This will take thousands of years to melt all of this ice, but it's happening. These are the ice shelf collapses in recent years that have been well documented. What's it mean for people who live on the coasts? Well, of course, they're concerned. Miami's already invested $4 billion in what's called blue sky flooding. Notice there's no storm clouds here, there was no rain. It's just a high tide, which, because sea level is rising and the tidal action is strong on a king tide, that the streets are now flooding when they did not used to with the frequency that they are now. If sea level continues to rise even a meter, best estimate now is about 2 meters by 2100. But if it rises a meter, this is all of Miami will be underwater. Most of the Everglades will be underwater. And all of these coastal properties, Fort Myers Beach, Naples, so on and so on, all underwater. Not only is sea level a concern, but the increase in energy in the Earth's atmosphere causes severe weather, more extreme events. And we're feeling it in Iowa. In Iowa, we feel the intense floods and maybe droughts. In California, it's the wildfires. In Florida, it's the king tides. In Louisiana, it's the hurricanes. So everyone is feeling the effects of climate change in different ways, but the damages are mounting. And you have to ask yourself, when is it more expensive not to act than to act? And I believe we've passed that time now. We need to have major investments in our infrastructure. We need to raise these bridges, raise the highways, raise the electrical substations, not allow people to locate in the floodplains, harden our buildings, have no more porous or permeable materials on the first floor of buildings because they're going to get flooded. We need only impermeable so we can just hose it down and keep going again. Lots of investment in weatherizing homes to against these events and to reduce our energy use, to reduce fossil fuels, to mitigate climate change. So we're being affected. What was a 100-year flood, you know, I recall I was only 8 years old in 1958 when Coralville closed the gates on the Coralville Reservoir. But I've read the history, and the developers convinced the city council that we'd never have to worry about flooding in Iowa City again. It would never overtop. And so we developed Mosquito Flats, and we developed all these areas that should have never been developed in the floodplain. And now we've already overtopped twice, 1993 and 2008, and then you lose all your flood control capacity. The 100-year flood in 1958, when we closed those gates at Coralville Reservoir, is now about close to a 25-year flood. So it occurs 4 times more frequently than it would have prior to the impact of climate change. We saw the Directo in Iowa last summer. It's the largest thunderstorm in recorded history. The damages were close to $10 billion. 40% of all the trees in Cedar Rapids were lost. Wind gusts of 140 miles an hour. It's a unique weather event. This is called a bow wave right here. I don't know if you can see it. It's like the bow of a ship. And it went 700 miles through the Midwest with these kind of wind gusts and damages. We have so few of these events, it's too early to say with certainty that this is a sign of climate change. And we know that there have been derechos. In fact, a University of Iowa professor named it originally in the 1800s, and the word has only now come back into use in recent decades. So there's so few, it's hard to know yet if it's due to climate change, but there's indications that we're getting moisture from the Gulf of Mexico because the seas are much warmer, and that warm, moist air overtops cold air beneath it and causes a phenomena like this. You remember Hamburg, Iowa in 2019. We had record snowpack in that year, and they experienced along the Missouri a bomb cyclone event. Very unusual rainfall event. The levees broke, but the levees had broken in 2011, and we paid millions of dollars to repair them. We're protecting 200,000 acres of farmland. I think you have to begin to ask the question, and we're right now spending the money to repair the levees again, but they're just gonna flood and break again for 200,000 acres. I think you have to ask, is that really a wise use of public funds? My own hometown, Davenport, Iowa, is the largest city on the Mississippi that has decided not to build a flood wall. So they invested in HESCO barriers. And in 2019, again, with the snowpack and the flood, the HESCO barriers held for 51 days. After 51 days, that was a record. The river stage at that flood stage was historic. After 51 days, they finally were undermined and flooded the downtown area. A similar event happened in Burlington, Iowa. In California, it's the wildfires. That's where my son lives. And two of my granddaughters, he had to evacuate his home this year for 10 days. The firefighters, CAL FIRE, they're amazing, absolutely amazing. They saved his home, and he got to move back, but many, many did not. 4 million acres were burned in 2020. And of course, lots of people have perished in the fires, like the in Paradise, California. The strength, it's not so much, so far the data indicates it's not necessarily the number of tropical storms that is increased due to climate change. The seas are warmer. It's the F4 and F5 storms that is increased. And that's due to, those are fueled by the warm temperatures of the sea surface, which have increased more than a degree Fahrenheit on average. At this time last year, and Hurricane Laura, which hit the Lake Charles, Louisiana area at the end of August last year, the seas were about 88 degrees Fahrenheit, almost like bathwater, fueling these storms. We had more storms last year than ever before recorded. 30 named storms. You may remember we had to go into the Greek alphabet to name them. And we had a record of 13 hurricanes that hit the US coast. So people ask me, I don't know, Schnoor, what do you think? Is it a climate emergency? Well, I would say so, because we've already only experienced 1.2 degrees Celsius, roughly 2 degrees Fahrenheit warmer temperatures so far, but it's just going to keep increasing. And what Paris was all about, and I was there, was to try to hold the warming to less than 1.5 degrees C. But if we can't do that, to less than 2 degrees Celsius, to try to prevent even more dangerous interference with climate. That requires about a 50% reduction in greenhouse gases in just 10 years in emissions. We have to turn this around, and we're running out of time. We don't have much time to do it. And we have to have net zero completely out of fossil fuel business by 2050. I tell my students, and they look at me with eyes this like saucers, and I tell them, in your lifetime, coal, oil, and natural gas companies are going to go out of business. In your lifetime, coal, oil, and natural gas, in that order, because that's the order of how they're affecting the climate. Coal already, the largest coal company in the world, Peabody Energy, has already filed bankruptcy. They can't buy assets, they can't borrow money, they can't sell their assets. Severe stress, as you can imagine, in the coal industry. It's happening in the oil industry too. At the moment, the prices are good on oil because people are ramping back up after the pandemic. But long term, they won't be able to sell their product either, and we're going to disinvest. That's what Paris is all about. That's what the new meeting is going to be about. I wanted to mention, because I know the Grannies are interested in species loss and extinction, biodiversity. In our lifetime, we're scheduled to lose about 1 million species. We don't even know how many we have. Best estimate is about 8.7 million species, and we're going to lose 1 million in the next 2 decades. The extinction rate is roughly 100 to 1,000 times the natural extinction rate. And there's a great report, if you get a chance to look at this, the IPBES on biodiversity and ecosystem services. It's not all climate change. In fact, probably habitat destruction is a bigger effect on species than climate change. But climate change is involved, especially with regards to the ocean, coral reef collapse, and to some extent, invasive species. I love this quote by J.B.S. Haldane, noted ecologist and philosopher, that God had an inordinate fondness for beetles. Of that 8.7 million species, we think that 1 million of them are beetles. 1 million of the 8 million. are beetles. There's 350,000 that have been named. We don't know out of the 8.7 billion estimated species, we only have Latin Linnaean genus and species names for less than 2 million of them. So we don't even know what we're losing. We haven't even discovered them. We don't even have names for them, but we're not taking care of the planet. I love E.O. Wilson. He's one of my favorite authors, Ed Wilson from Harvard University. He says that we need a plan to cooperate with countries and dedicate in some way, not all national parks, but dedicate in some way half of the earth to preserving species. And I like this quote: when we debase the global environment and we extinguish the variety of life, we are dismantling a support system that is too complex to understand, let alone replace it in the foreseeable future. Now, the Paris Climate Agreement. My wife, Jan, and I were there in December 2015. I was an official member of the media, so I got to attend all the meetings, and I must tell you, it was really of historic importance. Never before have all the countries agreed, first of all, that climate change is a big problem and that we're going to throw in together to do something about it. Now, it's true that it's a voluntary agreement. There was no way that we could take a treaty back to our Senate and get it passed, even in the Obama administration. No way. And not only the US, but other countries as well. So it all rests on soft law or on peer pressure of one country putting pressure on the other country to do what they say they need to do, what's best. In addition, for the first time, it shifted world finance. We're really beginning to change how we look at investment on a global scale. And this is big. And it means that we're trying to address how to fund the countries that are greatly affected by climate change, yet they had no role in causing it. I was able to take some students with me to the Paris talks. One of the outcomes of it, these are the two most important outcomes shown here: nationally determined contributions. Every country made a pledge, if you will, of how they're going to reduce their emissions and when they're going to do it by. It wasn't the same pledge for every country. Developed countries made larger pledges than developing countries, but everybody is involved. Every country, 194 or 5, signed the pact. And then the second most important thing is the Green Climate Fund here. And it's estimated to need $100 billion per year to try to relieve these most affected countries. But I'm sad to tell you, only about a small fraction of that has been pledged so far. I took a page from the meme that you may have seen on social media, how it started and where it's going. But it started in Paris in 2015. That was a remarkable agreement. We celebrated, my wife and I, that night. It wasn't clear that we were going to get everyone to agree, but they did. However, you know, in the meantime, it hasn't been going so well. Things are looking up right now. I'm rather much more optimistic. And how it will end, I really can't tell you. This spaghetti diagram here shows all the possible outcomes on our emissions that could happen from 2020. Here we are. We could follow business as usual and just get hotter and hotter, 5 degrees Fahrenheit warmer. We're kind of following this black line now, but we need to follow the blue line to decrease emissions abruptly by 2050, as we said, and even have negative emissions. We need to plant forests to take carbon dioxide out of the atmosphere, in addition to reducing our fossil fuel use. You might be interested in a list of the most vulnerable nations. They have to do with coastal nations, island nations, sub-Saharan African nations where climate is changing so fast that they can't even practice agriculture any longer. And the UN is trying to, it's hard work, trying to work out the metrics of how you, who's the most needy. Again, these countries almost did nothing to cause climate change, but they're suffering the most. The Maldives are abandoning islands and inhabiting new places because they're going underwater. There's been some progress on a green climate fund to help these countries, but it's far from what is needed. We've only contributed about a third of our pledge, which was $3 billion in the United States. We pledged about $9 per person per year. That's a pretty healthy tax. But look at Sweden, pledged $59 per person per year to this, and Norway, $50 per person per year. Here's the stress. When I talk about finance, that's what's going on right now that's different. The question is, who's going to fund companies that have big carbon footprints? And we may have to stop funding them. The red ball here is how much oil and gas we have in proven reserves. This is mostly owned by the oil companies. Proven reserves in the ground. This is how much we can burn if we want to stay under the 2 degrees Celsius warmer climate. So we can't even burn what we've already discovered. We cannot. We have to keep it in the ground. We only have about 11 years left at current rates of emission before we have basically catastrophic changes in sea level rise, storm events, hurricanes, wildfires, agricultural failures. The oil companies have $4 trillion invested in these proven reserves. But if we can't burn it, they're going to be stranded assets. And there's going to be, from a political standpoint, there's going to be hell to pay to make this transition. So the stakes have been raised since I was in Paris. The new event is Glasgow. It was supposed to be in 2020, but it had to be delayed because of the pandemic. The UK is host, and right now the UK is preoccupied with trying to solve their trade issues and to get trade agreements with every country having left the European Union. But what has changed, the stakes, this is what Obama pledged, 26 to 28% reduction in emissions and 80% by 2050. Now, when we go back to Glasgow in November of this year, it's expected that we'll enact a 50% reduction in fossil fuel emissions in the next 10 years. That's what we need. And 0 by 2050. We're getting out of the fossil fuel age. I tell my students it's been a good run for 200 years. We've heated our homes, manufactured our clothes, powered our cars, our industry, our airplanes. We've done everything with fossil fuels, and it's got to come to a screeching halt. The crucial issues right now are ending oil exploration. Our country's going to tell the oil companies they can't explore anymore, and maybe more importantly, to stop investing in them. Ending fossil fuel financing overseas. No more financing by US banks for overseas if they're emitting carbon dioxide. Limiting airline travel, debt relief for the Green Climate Fund, carbon markets. Every financial decision, according to Glasgow, will have to take climate change into account. Every loan, every contract will have to take climate change into. So there are some good things happening. Biden is putting the U.S. back into an important position in these negotiations. And I have to add my inspiration, Amanda Gorman. If you get a chance, listen to her on the internet recite the poem Earthrise about climate change. Isn't she amazing? Our poet laureate who spoke at the inauguration. What do we got to do? We have to take action now. We have to mitigate. The countries really, I don't look to them where the action is. The action is with cities, states, businesses to strengthen the Paris Accord. The countries are being slow to act. We need some kind of tax on carbon. Citizens Climate Lobby argues for the fee and dividend. That's a very good program. But I think Biden is kind of leaning towards, to be honest with you, it looks to me like command and control legislation. He would like to pass legislation. If you would have told me when I gave my first class on this in 1990, that here we'd be in 2021 with no energy legislation, no plan, and no comprehensive climate change legislation in the US, I wouldn't have believed you that we could go this long without a plan. We have a plan. We just burn whatever is cheapest, and that's not serving us very well. We have to adapt. We talked about it, hardening our infrastructure. Hopefully, this is going to be the next thing Congress does, is begin to make a massive investment in our infrastructure, which is sorely behind. And we have to reduce emissions now within the next 10 years. I do believe we can do this. This is how we're going to create jobs. It's the engine for economic development in the future. It's much, much cheaper, whatever investment we make, than the damages that we're paying now in climate change damages. So don't be fearful. Look at this as an opportunity. It truly is. We can do this and we can prosper. Thanks very much, Grannies.